So first thing we're going to do is figure out the critical values. And to do that, we need to figure out the derivative of our function. So derivative of f of x, we get 3x squared plus 2x minus 5. So we want to know when that's equal to 0 or when that does not exist. Since this is a polynomial function, it's always going to exist. Right? It's continuous. It's not going to have any discontinuities. It's going to be differentiable all the time. It's just going to have derivative that's equal to 0 from time to time. So to figure that out, we have to factor and set that equal to 0. So we're going to end up with 3x and x. We end up with plus 5 and then minus 1. So either x is going to be negative 5/3 or x is going to equal 1. Those are our two critical values. So we're going to take those critical values and put them on a number line. So let's make a line. And this number line is going to tell us about the derivative of our function. So I'm going to label it with derivative of f. Because down the road, we're going to look at some number lines that have the second derivative. So you want to label it so we know what we're talking about here. And on the number line, we're going to put 2 marks, one for each critical value that we have. So negative 5/3 and 1. So we're putting the critical values down at the bottom. All right, critical values on the bottom. And up top, we're going to tell why they're critical values. So in both of these cases, they're critical values because the derivative equals 0. In some cases down the road, we'll have it where the derivative is undefined. Right? So we put a u here, so we know that it's an undefined derivative. But those are our critical values. From that graph up above, we saw that between the critical values, the function was always doing the same thing. It was always either just decreasing the whole time or increasing the whole time. So all we need to do is test a number kind of in between these critical values and then on either side to see if the derivative is going to be positive or negative in that interval. Because all the points either in between here or to the right of 1 or to the left of negative 5/3, they're all going to have the same slope, sign at least. They're all going to be positive slope or they're all going to be a negative slope. So let's try putting in 0, right? So that 0, we can use any number between negative 5/3 and 1. I want to plug that into my derivative, right? Because this is the derivative number line. I'm just trying to figure out, is the derivative positive or negative at 0? So I don't even need to know the value. I just need to know, is it positive or negative? Now, we could just put with 0, it's pretty simple. If we put it into this equation, we get negative 5, right? So we're going to get a negative value. Now, for a lot of cases, though, plugging in numbers to this function, and it depends on the function, it could be a lot more complicated. It can be difficult to figure out that way. So what you can do is use the factored form. If I put 0 into this first factor, what do I get? Positive or negative number? Positive, right? Doesn't matter what it is, just if it's positive or negative. If I put 0 in here, I'm going to get a negative. So if I take a positive number times a negative number, I'm going to end up with a negative number. All right, so that's kind of a simple way to fill out this chart. So I'm going to do something to the right of 1. It could be any number to the right of 1. I'm just going to pick 2. If I put 2 into this first factor, I still end up with a positive number. If I put 2 in here, I get a positive number. So a positive times a positive gives me a positive number for my derivative. So all the numbers to the right of 1 are going to have a derivative that's positive. All the numbers between 1 and negative 5/3 are going to have a negative derivative. And then we want to check over here. I'm going to use negative 2. If I put negative 2 into this first one, we're going to get a negative number. Put negative 2 in here, I get a negative number. And a negative times a negative gives us a positive. So remember what we wrote up top. When a derivative is positive for a whole interval, that means the original function is going to be increasing. So in these two intervals right here, from here, our original function f is going to be increasing. When the derivative is negative, our original function is going to be decreasing. And that's what we're looking for. When is f increasing, and when is f decreasing. So it's increasing from negative infinity to this critical value, negative 5/30. And it's also increasing, so we have union there, from 1 to infinity. From here, from this critical value to the right. Increasing on those intervals. Then it's decreasing between these 2 points. That's when the derivative is negative. So that's going to be from negative 5/3 to 1.